Hello again. Section 12.3 is all about simplifying algebraic fractions. So right, fractions, one number on top of the other. Algebra means numbers and letters on top of each other, and then you've got to simplify them. Now the fact that it's here implies that many of them can be factorized, many expressions can be factorized, and that can lead to simplifying. Let me give you the first one. Now these are grade A all the way, as I like to say. Move this over a bit so I can focus in the right place. Right, page 136 only, small section. I've got here c squared plus 2c plus 1. Oh, by the way, the background is we went to the what do you call it now, all the mountains in England. Where's all that? Oh yeah, Peak District, and we sort of stayed there one half term of February, and it was miles away. It's freezing cold but stunningly beautiful. So that's a picture that we took there. Right, I've now got to simplify this. Please don't get crazy and start saying, oh yes, c and c goes. No, it doesn't. Look, you've got a quadratic upstairs, therefore simplify the quadratic, factorize it. Look, c squared, c times c. How do you make 1? 1 times 1. Both positive. That will make 2 c's, alright? We've done quadratic factorization, therefore I don't want to explain in detail how I get to this point. Now divide. Now look, 4 and 4, that can be factorized. Take a 4 out, that's not, grade anything, it's D, isn't it? Less, E. Very simple. Take a 4 out of each, I'm left with c plus 1. Now study. Yeah, look at this. The c plus 1 bracket cancel with the c plus 1 bracket underneath. What am I left with? C plus 1 all over 4. So that, my friends, is just that little bit there. Isn't that elegant? Right, that's the first one. Let's go to question 3. Question 4 actually gets quite tough quite quickly, but they're a lot of fun. So t squared plus 11t plus 18. Are they all pluses? Yes, they are. That implies it's easy. Divided by t squared plus 9t plus 14. Right, factorize the top bit. Well, t and t, obviously. How do you get 18? 2 9s? Yeah, 2 and 9 make 11, no problem. So 2 and 9, everybody is positive. Divide by, here we go, t and t. How do you make 14? 2 and 7. 2 and 7 will make a 9 any day. And they're both positive. And look, let's just go to red. Goodbye to you and goodbye to you. What are we left with? We're left with t plus 9 divided by t plus 7, and that's beautiful, isn't it? Lovely, lovely, lovely. Right, next one. Let's try something a bit more scary. This one with all the minuses on it. Right. Y squared minus 2y minus 3. Are you scared? Right, y squared minus 6y plus 9. Let's just factorize on the right hand side here. So that's the top bit divided by the bottom bit. Right, this lot. Y times y, y squared. How do you make 3? 3 times 1. No choice in the matter. How do you make minus 2? Well, I want minus 3 and plus 1. Is that alright? 1 times minus 3, minus 3. 1 plus minus 3 is negative 2. And that will give me minus 2y eventually. Bottom bit, y and y. How do you make 9? 1 times 9, but 1 and 9 won't give me a 6. But 3 times 3 will give me 9, and 3 plus 3 will give me a 6. They've both got to be negative in order to get to minus 6. Minus 3 times minus 3 is, of course, plus 9. Now look, switch into red. This bracket term and that bracket term goes bye-byes, and I'm left with y plus 1 all over y minus 3. And that is very, very handsome mathematics. Next one, going back to yellow. I've just done question, I haven't got a clue, question 6. Let's go question 9 and see what happens. 2x squared, oh that's grade A. In fact, they say they're all grade A, they're a bit easy for that. This one may not be though. So x squared minus 4. Yeah, I'd definitely rate this at grade A. There's plenty happening here. Right, going upstairs. Bracket, 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 bracket. Worry about you in a minute. Right, 2x and x. How do you make 6? 1 times 6, 6 times 1, 3 times 2, 2 times 3. Either way, I want to end up with 1x, so let's just try it, shall we? Yeah, if I put a 2 there and a 3 there, I think that's going to work, because look, x times x is x squared, x times plus 2 makes 4x, and 3 times x will be 3x, but if I make it negative, then 4x take away 3x is uno x, and minus 3 times 2 is minus 6. So I know I've got that right. I did say I wasn't going to show you how I got it, but you know, you're driving me to help you to the point of exhaustion. Right, x times x, 2 times 2. Remember, difference of two squares, plus, minus. And look, bloody bloody blah, they've gone bye-byes. X plus 2 has gone. Don't like writing it in red, doesn't show very well. So what have I got? I've got 2x minus 3 upstairs and x minus 2 downstairs. That's as far as I can go. So that is that. Alright? And that was question, I haven't got clue 9. I suppose 11 is the hardest one. Let's just do it quickly. Or maybe do some of these starry ones. Let's do a starry one. Right, here's one, a starry one. X cubed, oh dear, that's not quadratic. That's cubic. X squared minus 2x. Oh look, it's not a bit crafty that. X minus 1. Now, factorise the top bit. What have I got? I can take an x out of u and u and u. So I'm going to factorise completely. Remember, take an x out, what's left? X squared plus x minus 2, and divide that by x minus 1. Please do not pick up your pencil and go doing, doing, lose the x's. That's not x underneath there. It's x minus 1. So show some love. Right, factorise the top bits. X, how do you make 2? 2 times 1. How do you get plus 1x? Well, the 2 better be positive, and the 1's negative, because 2 take away 1 is 1, and minus 1 times 2 is minus 2. And now divide that by what I see underneath. Put it in little brackets so it matches his brother. Take my red and say, good night, sweetheart. And what am I left with? I am left with x multiplied by x plus 2. Don't bother multiplying out, because it's more simplified in its factorised form. So that is equal to that. And that is really pleasant. I'm going to stop there because it's going to get really ridiculously hard, and you don't need to go that far. I've shown you how to simplify algebraic fractions. It always involves factorising. It will always involve cancelling a top factor with a bottom factor that are identical. It may involve the difference of two squares, as you saw in the example right there. Either way, it's very handsome, elegant mathematics, and I think quadratics are an awful lot of fun.